Hi, in this video I will demonstrate doing an OpenStack Virtual Baremetal, or OVB, deployment on a public cloud. The reason this is a big deal is that in the past OVB required some non-production changes to the host cloud. With some of the recent improvements made to OVB, that is no longer necessary. You can now do an OVB deployment on any cloud that exposes the necessary features. I'm also going to take this opportunity to do a full TripleO deployment on OVB, so if you're interested in seeing what that looks like, this will also be useful. Now there are a whole bunch of details about doing this that I'm probably going to have to gloss over because it would be really boring if I tried to talk about all of it in the video. So I'm also going to do a companion blog post, and I will link that from the video description. That should cover all of the nitty-gritty details that you need to know, and it's a little bit easier to skim if you want to. Today I'm going to be doing this demo on VexHost, and the reason I'm doing that is basically it was the first public cloud I found that exposed all of the necessary features to do OVB. There may be others now, and if so, I'd certainly like to know about them, but Vex was the first one I found, so that's what I'm using. So we'll start off by taking a look at the environment file that we're going to use to configure OVB, and you can see that here. We'll scroll back up to the top, and you can see this is just the standard OVB configuration file. This is all documented, and things to note, I'm using the V2 flavors. I found that they performed a little bit better. There are some caveats to doing that, specifically around the images that you use. The V2 flavors have a 0 disk size set on them, so that basically means that they are going to use whatever the virtual size of the image you boot is, and the original iPixie boot image for OVB was only a few meg, and it only looked like it was a few meg when you booted it. So that obviously was a problem. There is now an iPixie boot 41 image in the OVB repo that has a virtual size of 41 gigabytes, which should be enough for most of your bare metal instances. So that's the actual iPixie boot image I'm using, and that's why. The BMC, I'm just using standard V1 flavor. That's not so performance critical. And the CentOS 7 base image that's provided by Vex. The rest of this stuff is all pretty standard until we get down to the undercloud settings down here. Again, you can see we're using the V2 flavor, and I've created a snapshot of the CentOS image. The default size of that image is only 8 gigabytes, which is not enough for an undercloud install. So I booted a V1 instance with a larger disk and then snapshotted it, so now I have an image that has a larger virtual size. You could also just upload an image of your own, but this was actually the simplest way to do it for me. And I think that's pretty much it for the environment file, so we will move on to the actual deploy command. And I'll copy paste that in here. And so we'll just take a look at the pieces of this. Deployed up high is just the deploy command for OVB. TripleO stands for TripleO on OpenStack, and it's basically designed to deploy an environment that has all of the bits needed to deploy TripleO in OVB. So that includes all of the networks, it includes an undercloud, it includes a few other things. We are going to name it demo, and we're also going to give it an ID of demo. I like to use IDs for my OVB environments, just because that way if I do end up booting another OVB environment in the same tenant, I can keep track of which resources belong to which. If you don't use an ID, everything will be named the same and it can cause problems. We will pull, so we'll wait until the heat stack is completed before we return from the command. And we're passing in the environment file that we just looked at, and then we're also passing in a couple of other environment files. The first one is this all networks port security, and what that's going to do is it's going to deploy some extra networks. So if we wanted to do network isolation in TripleO, we could do that. I'm not actually going to do that in this demo just for the sake of simplicity, but it's a good idea to just go ahead and deploy with all the networks anyway. It won't hurt anything, and if you do change your mind later, then they're available. The other part of that is the port security, and that's telling Heat to use the neutron port security extension to allow things like pixie booting and DHCP from the undercloud. Normally, Neutron won't let you do that for security reasons, but in our case, we want to do that. And then the final environment is just the create private network, and all that's going to do is create a local tenant network that will attach all of these instances to. You can also create this by hand, which is why there's a separate environment for it, but just for the sake of simplicity, we'll let OVB do it for us. And so we will go ahead and kick off that deployment, and this will take a few minutes, so I will probably fast forward through this bit. Okay, and you can see our OVB environment has been created successfully now, and so we can move on with the deployment. One other thing I should note before we go any further is there are environments out there to configure boot from volume for some of the instances, and you should make sure that you don't do that for the bare metal instances if you're doing a deployment on a public cloud. The reason is that you need to rebuild the bare metal instances between each deployment so that you have the iPixie boot image again so that they can pixie boot. Nova can't currently rebuild images or instances that are booted from volume, so you won't want to do that, or you'll have to completely tear down the entire environment and rebuild it each time. So the next step will be to create a nodes.json file that we can import into Ironic once we have that deployed. So we'll do that with the build nodes.json command, and we'll pass the env demo file. And the reason we're passing a different environment file here is that we use the --ID option in the deploy command, and so that creates a new environment file that contains all of the identifiers with the ID appended to them, because that's what we actually care about for going out and retrieving the information about the instances. And this shouldn't take too long with just 2 instances, and there we go. So you can see we have all of the information that Ironic is going to need. So we will go find out what our undercloud IP address is. And you can see OVB has assigned a floating IP to it. So we'll go ahead and copy that, and we will copy nodes.json to that address. And now we are done on our local machine, so we can go ahead and SSH to that undercloud. And so from here we go ahead and start with the TripleO deployment on our undercloud. And the first thing we're going to do is enable all of the TripleO repos. This is a little bit more complicated than I would like at this point. So you're going to see a big ugly wget command in here, and the reason for that is we don't have a well-known location for the TripleO repos package yet, so you have to go out and actually look for it in the current RDO trunk repo. Alright, so you can see we've used TripleO repos to create our RDO repos locally, and so now we can move on to the undercloud install, and the first thing we need to do for that is to create an undercloud.conf file. So we'll go ahead and do that, and we're just going to do something really, really simple. These are pretty much the minimum settings needed. I always recommend creating or setting the undercloud hostname option, just because that can avoid some issues with hostname related problems. And the local MTU setting is needed because we're running in a tunneled network environment, so there's some tunneling overhead, and our actual MTU on the interfaces is 1500, but that overhead means we need to drop that down a little bit. 1450 is generally a safe value for that, so that's what we're using. Now the next step will be to install the TripleO client, and that will provide us our OpenStack Undercloud install command. So we'll go ahead and do that. And while that's running, I will also note that for creating those undercloud.conf files, there is a web app available that can help you out with that and kind of sanity check your configuration, although the undercloud install will also do that. But it can be helpful, and it will also auto-generate some values based on just a few inputs to just make it easier, because there's actually quite a few configuration options for the undercloud. And so you can see there's quite a few packages that get installed along with TripleO clients, so this will take a while, so we will probably skip ahead to the end. Now that we have TripleO client, we have the OpenStack Undercloud install command, so we will go ahead and run that. And once again, this is going to take a while. It's basically doing a full single node deploy of OpenStack, so obviously that's going to take some time. So once again, we will skip ahead to the end. Okay, we have our undercloud, so we can move on with the deploy process. You can see we've also sourced the RC file, so when we need to run OpenStack commands, we'll be ready to go. The next thing that we need to do is some more MTU configuration. So the first thing we'll do is set the MTU on the provisioning NIC. And then the next thing we need to do is configure the DNS mask option for MTU. So you can see we're doing that with the DNS mask ironic.conf. This is just how TripleO configures Neutron, so that's why the names seem a little bit weird. And then to actually make that change stick, we need to go ahead and restart the Neutron services. And now that that's complete, our next step will be to build images. And the first thing we need to do is set the dibyum repo.conf variable. And we're just setting that to all of the TripleO repos that we had installed before. They're all named DeLorean something or other. And then to actually do the image build, we run OpenStack overcloud image build. Once again, this is kind of a long process, so we will go ahead and skip to when it's finished. Our images are built, so now we can upload them to Glance, and we'll do that with the OpenStack overcloud image upload command. Now that we have images, we can import the nodes that we had created earlier. We'll do that with the nodes.json that we uploaded. And the command to do that is OpenStack overcloud node import. And we are going to pass the introspect option, and I'll talk a little bit more about that in a minute. And we'll also pass the provide option so that the nodes will be available once they're imported. And then we just give it the file. And the reason that I'm running introspection on this in this particular environment especially is that because the flavors have a 0 disk size, the nodes.json is going to have incorrect information in it. And if we run introspection, it will go out and update all of those node details with the correct values. So it's working around a bit of a limitation in OVB. And this will also take a little while, so we'll probably skip ahead. Our introspection and node import have completed, so now we should see that we have a couple of available nodes. And there we are. So there's one more step that we need to do before we actually start our deploy, and that is to set a DNS name server on the control plane subnet in the undercloud neutron. And the reason we need to do this is that now that TripleO is containerized, it needs to have a proper DNS name server set, or some issues will occur. So to do that, we are going to run OpenStack subnet list and get the UUID of the control plane subnet. So we'll grab that, and then we do OpenStack subnet set on that UUID, and it's the DNS name server option, and we'll just use that one. And that completes our deployment prep. We can go ahead and run our overcloud deployment command now. And that's the whole thing. So we'll go over this again piece by piece. So this is OpenStack overcloud deploy. That's just the standard TripleO deployment command. -- templates, that's telling it to use the TripleO heat templates on the undercloud that were installed from package. The other option is to deploy from a plan, which will contain the templates, but just for simplicity's sake, we're going to use the local ones. Libvirt type of QEMU, that's because we're running in a virtual environment and I don't want to mess around with nested virt. I don't even know if it's enabled in this cloud, so we just won't worry about it. And then I also always disable telemetry when I'm doing these tests because I generally don't need it, and it saves a little bit of time and memory if you don't deploy it. So now we can go ahead and start that, and in a little while we should have a fully functional virtual overcloud. So we'll cut away until that is done. So now we've got our overcloud, and we can go ahead and run a real quick smoke test. For this, I'm just going to use a script from the TripleO CI repo that I like to use because it is just dead simple. It's not going to do a whole lot, just a very, very tiny little bit to verify that all of the services are actually running. And I'm not going to go over too much in detail about exactly how I'm running this. It's on my blog already if you really want to know, and if you're doing one of these deployments, you probably have something specific you're looking to validate anyway. So this particular test might not be relevant. But for our purposes, it can verify that our virtual overcloud is working. So here we go. And here again, this will take a few minutes, so I will probably fast forward through it. And good news, looks like everything is working. So we have successfully done a virtual TripleO deployment in a public cloud. I hope this was interesting, and thanks for watching.